Okay, let's do another example problem. So let's say that you have someone that's shooting a pistol at a target. Okay, and let's say the target is a distance of, let's say the target is a distance of 50 yards away. Okay, so let's say this is a 9mm pistol and has about 1200 foot per second muzzle velocity. It can be, I mean, depending on the exact load, it can be a little more, a little less, but about 1200 foot per second. So the question is, when the bullet hits over here, assuming it's moving straight horizontal, how far below has the bullet fallen? So in other words, as the bullet's going, it's actually falling a little bit because of gravity. So the question is, how far does it fall? Okay, so how do we do this? Well, pretty much the same thing as before. We say x equals x naught plus v x naught t plus 1/2 ax t squared, and y equals y naught plus v y naught t plus 1/2 ay t squared. We know that gravity is going this way. I'm going to put my origin right here. I'm going to say that way is positive x, this way is positive y. Why do I do it that way? Because I feel like it. I can do whatever I want. X naught, y naught is 0. There's no x acceleration. There's no initial y velocity. So x is just going to be vx naught t. That's my vx naught right up here. Okay, and y equals 1/2 gt squared. Aha, what do I know? I know x, I know this. I know 1/2, and I know g. In order to find y, the distance the bullet falls, all I need to know is how long it took the bullet to get to the target. I can find that here. Okay, so that is going to be x over vx naught. Well, 50 yards. Okay, so how far is 50 yards? Well, 50 yards is 150 feet. Remember, we have to have all the units working out. So 150 feet divided by 1200 feet per second. Okay, so that's going to be equal to 0.125 seconds. So basically 1/8 of a second. Okay, so y was 1/2 gt squared. So y is going to be 1/2 32.2 feet per second squared times 0.125 seconds squared. So y equals 0.252 feet. How far is that? Well, that's going to be 3.02 inches. So the bullet would actually hit about 3 inches below where it was aimed, given these circumstances right here. Okay. Now, question would be, all right, so suppose instead of a distance of this distance, what if it was twice as far away? Would it fall 6 inches? What do you think? Would it fall 6 inches if it's twice as far away? Well, if the distance is twice as far, then the time is going to be twice as long. So that means the time, instead of being 0.125 seconds, the time would be equal to 0.25 seconds. So a quarter of a second. And so the distance would be 1/2 32.2 feet per second squared times 0.25 seconds squared. Okay, so that is going to be equal to 1.01 feet. How far is that? That's about 12 inches. So it falls 3 inches for the first distance. But if you double the distance, it does not fall 6 inches, it falls 12 inches, 1 foot below where you're aiming. And that is because it's not moving linearly, it's parabolic. So it's getting steeper and steeper as we're going. And so this is something to think about and remember when you're talking about this kind of trajectory. So this is ballistic motion, this is projectile motion. Also should point out another interesting thing here is y equals 1/2 gt squared, and I use 32.2 feet per second squared because I used feet earlier. Could I have instead used 9.81 meter per second squared? Well, the answer would have been 1/2 9.81 meter per second squared. Let's go back to the original one, 0.125 seconds squared. And so the answer would have been, actually, there's no problem here because we're not mixing units. We're going to get an answer of 0.0766 meters, or in other words, that's 7.66 centimeters. Okay, which is about 3 inches. And so, yeah, we could have done it this way. It looks like we're mixing units, but we're not mixing units in the equation itself. Okay, and so this is another example where it is very important you keep track of your units. And if you really understand what you're doing with the units, then you can actually, do quite a bit of stuff with it. So, so this is another example problem right here, and just thought I'd point this out because this is again example of projectile motion.